We're going to take you along a little bit of our journey today of getting to the cloud and building applications in the cloud at Global Payments, and how we're using Looker and BigQuery to scale up around the world for an application that we've built. Just a little background, Global Payments, large payment processor headquartered in Atlanta, Georgia. $4 billion in net revenue last year. If you don't know much about us, about 2.5 million customers that we've given some sort of payment solution to around the world, and about 11,000 employees is the size of our company. We have a strategy at Global Payments. It's about software-driven partnered solutions around the world, an omnichannel experience. You've seen that in some of the presentations around here. We want to make sure that we can deliver things across multiple channels around the world and get into faster growth markets. One of the ways we're going to expand those markets is going to the cloud. Probably about a couple years ago, our chief product officer, Frank Young, had a mission. He wanted to create a best-in-class engagement platform, not a BI platform, not just a reporting platform, but something that attracted customers, created stickiness, and was something that we could be proud of at Global Payments. So he partnered with us, and about that same time, our CIO, Guido Sacchi, put us on a cloud-first strategy at Global Payments. He knew that we needed to have a multi-cloud, cloud-first strategy to deliver things around the world. We had to have reduced total cost of ownership. We couldn't do things on-prem. You've heard that theory many different places. So he launched us on that strategy. We needed to build the technology solutions that our customers would like around the world. We needed a platform that we could innovate on and deliver new products every year, every quarter to drive business. And we need to do it securely and safely in the cloud. You've heard a lot of things about security in Google Cloud, but those were really the driving factors that launched us on this journey that we've been on. I don't know where all of you are in your journey, so I'll review a little bit. This is a couple years ago. We started to take a look at different vendors, different things. We enlisted the help of our architecture department led by Ali Fawaz to look at some of these factors to help us out. Probably you guys had these same factors, but I'll review them. We needed not just a BI tool. Everybody seems to have 1, 2, 3 of them. BI tools didn't work for the mass markets. We needed something that could provide embedded BI in that engagement platform we're talking about. We needed RESTful API enables. Everybody out here is probably trying to produce APIs, trying to get out there where people can code to your APIs rather than us have to code for them out there. We needed something that was responsive design. Everybody in here has a different device, a different modem of connecting. We needed to make sure that that platform was able to be displayed on any device, visually appealing to anybody that wanted to do business with Global Payments. We needed a powerful abstraction layer so that when we change data that changes very readily out there, we could put something in between. That's where we use the Looker platform, and we'll get to that later in there. And we needed to integrate with the cloud. We have all evaluated many different cloud vendors too. We chose a multiple cloud strategy. We got that. But for this application, we chose Google Cloud Platform. We needed something that could power a data lake. Data's king. You got to have data to do anything these days. We evaluated things on the technology now and where we thought things were going in the future. You have to look forward a little bit. Things change very fast out there every day. The total cost of ownership was a big factor for how we wanted to produce our applications in the cloud. Security's number one. We're a payment processor. If we don't keep your credit card number safe and all your personal data safe, we're out of business. So we needed to use that as a guiding principle. And a data center region availability. Everybody's heard of GDPR. India's put some rules in lately to where you may have to put your application locally, you may have to put your data locally. So forward thinking, this has allowed us to take some of those factors into account. Why we chose Google Cloud Platform and Looker out there. Again, GCP, Looker, BigQuery, and App Engine are the main components. Jason's going to walk you through the design and the pieces we used to get to the platform that we're rolling out. We needed a customer-first design. One of the things that we learned over time was you must listen to the customer. You guys have all probably heard it. But we actually used my team plus some partners to build a prototype almost 2 years ago that we launched out to the customers. We got feedback back. In January of 18, our design team, led by Claire Bowden out of Ireland, redesigned this thing, listened to the customer. In January of 18, we really started building this out for the customers. We went to beta in the summer, and we have been getting feedback from the customers, and I'll tell you where our journey has gone to a little bit later. We needed it API enabled. Again, if we cannot enable an API for our customers, because we serve everybody from the small mom and pop to the medium-sized guy with 4 franchises to the Verizons of the world. So this architecture that Jason's going to talk about services all of those customers. Again, any device, anywhere, and then we wanted to make sure that we could launch on an analytics platform, Google BigQuery, and a lot of the things that GCP that you're hearing around all these sessions could provide, and we knew would enhance our offering to all of our customers. Our custom-built application looks a little like this, and I'll go into it a little bit more after Jason gives you a little more of the nuts and bolts of the architecture. But we need to scale to any enterprise. We need to scale to your mom and dad may have their small business. It needs to be useful for them. It needs to be useful for the medium guy and the large guy. It needs to be extensible to any platform and highly customizable, because it has to be one size fits all for our users. What I'd like to show you now is, if you could switch to demo 1, is, hold on. This is where a demo. There we go. Can you switch to demo 1? There you go. This is a little marketing video that our team has put together, the portal that we're launching. Built on top of GCP with the components that Jason's going to describe, and I'll let him get up here and talk about it. But this is a portal designed for everybody around the world that we do business with today to get the information about the transactions we process for them. Looks pretty slick. In my opinion, I think our design team's done a great job. But I'll let Jason tell you a little bit about how we built that.
Cool, thanks, Mark. So like Mark said, we've kind of went on this journey probably about 2 years ago. We started, we kind of got we decided we were going to go all in on the cloud, which is a pretty big change for us. And can you guys go back to slides? There we go, we're good. So I'm going to talk a little bit on what we actually built here. So obviously it's a modern web application. It's designed completely in React. Everything's hosted in GCP. We went with a microservice architecture, as everyone is doing nowadays. That gives us some extensibility. The application does a lot of things, but I think the most important thing that we're here to talk about today is how we're getting this data from our data lake to the customers. And it's a little non-conventional here, but what we're actually going with is streaming this data from BigQuery itself to the customer in real time. There's no reporting layer in between. We're not doing any pre-aggregations that you would typically see with like a Lambda architecture or something like that. Pretty standard web application. What I want to focus on today is the reporting API, which is how we're actually getting this down. As Mark alluded to, BigQuery and Looker are keys to that. So let me start with what our goals was for this, right? So we have some disparate data sources. Some things come in batch. At the end of the day, I'm sure a lot of you have that. We also have some stuff that comes in real time. So there's a challenge there. You can't go with kind of like a batch layer where you process it nightly because we have streaming data coming in at the same time. So obviously that's a challenge. There's been solutions to do that. I don't know if you guys heard of the Lambda architecture where you'll kind of take your batch layer, you'll take your streaming, you'll kind of amalgamate them in a API layer and serve that up to the customer. That was one option. The other thing we need to do is we want some self-service, right? In previous lives of this application, we found ourselves having lots and lots of different reports that our team would have to customize and design. They're really just permutations around other stuff. So we would love to give some self-service to the customer and let them kind of say, I want this column, I want that column. You'll see where that comes in. The third thing is, we want it relatively fast. This will you'll kind of see as we get in, this is the biggest challenge to this architecture of going directly to BigQuery, is getting that speed to web level, right, web speed. And then obviously fault tolerance, right? When you're going through and you're building a data lake, you really don't want to, you want to be able to start from scratch, right? You want to be able to go back in and rebuild the entire thing. It's kind of the mindset of the whole map reduce. You know, you have the data lake and you want to be able to rebuild that from scratch if your design changes, say aggregates change, anything like that. Right, I need to be able to go back and start from scratch and not have, you know, basically an immutable data set at the end of the day. So with those goals, what we've ended up building is a reporting framework that kind of lives on what we're calling a multi-layered data lake. So you can start with the regular batch data comes in files. We're throwing all that into GCP storage buckets. From there, we move on. We essentially move it as is to BigQuery, one for one, right? And we're calling that our trusted layer. This is kind of our global payments. These are not industry standard terms. This is what internally we are calling these layers. So the trusted layer is pretty much straight in from a one for one, like for like from the data set. And then we'll go through and we'll put some metadata on it. We'll protect sensitive data. That, you know, we're not going to persist things that shouldn't be persisted. At that point, we move it to a second layer, which is also in BigQuery. So these are BigQuery to BigQuery jobs. And that's what we're calling the transform layer. So this is where we're going to put some data quality rules on. We're going to go ahead and normalize things like dates, data types, right? Get that data in a clean state where you can put other tools on top of it, whether it be, you know, eventually AI, ML, right? That will come off the transform layer. This is our normalized kind of data quality. Now, I can always go back and rebuild that from the bucket to the trusted to the transformed. The key, I think, to this design, though, is really what we're calling the consumption layer. And this is kind of equivalent to a batch layer in a more traditional big data architecture. All the consumption layer, I think of the consumption layer almost like a materialized view. This is where we can take multiple data sources that came in from the transform layer, aggregate them together, flatten them out, run metrics on it. If we have some common like KPIs or any aggregations that we want to run, we put them in the consumption layer. The problem is, you know, then how do you get that to the application, right? I really don't want all my applications writing directly to BigQuery, you know, especially from the internet. So this is where we have our consumer systems, which is, you can see up there, this is Looker. And what we're using Looker as is really that abstraction layer to our data lake. Got a little slide here on Looker. Looker's given us a lot of stuff. So is anybody familiar with Looker? If you're not, the platform itself is really just, it's its own modeling language, really XML based, where you can basically define a contract and put the data behind the scenes, and Looker will go ahead and form the query up and return the data back to you. This helped us a lot because when we were building this application, we also came at it from two prongs, right? We were building the web application, the reporting layer, and the data warehouse, the data lake, all those layers at the same time. So what we did with Looker is we basically used Looker as a contract, right? The model that we defined in Looker, we might have stubbed some of it out. Now the front-end team who's building the APIs can start coding against that, while the back-end ETL teams are actually fulfilling the data sets behind the scenes. And if we need to change anything, we change it at that one place. That kind of gets to the idea of the consistent, no matter who's looking into this data, if it's going through our Looker model, everyone's going to get it exactly the same. Looker also offers an API, which is key to this kind of design. So they have a very robust API where I can do filtering, column selection, things like that. Anything that's in my model, I can essentially query through the API. They almost have an API first mentality. So I don't have to write SQL for my code anymore. I can use Looker just like another API, data API. It just happens to have BigQuery behind the scenes. Looker also gives us visualizations. So there are embedded visualizations you see kind of on the screen right there. You know, you have the little the charts and graphs. Those are all driven from Looker from the exact same model that we get the data from, which is, you know, it really helps in the development efforts. I don't have to do any extra development to get a pie chart around the same data that I already have. I just basically configure what's called a look. I call that, I can embed that in my application. You'll see that later. Mark's going to show a little bit more of the app. Paging. It's another thing we do directly in the looker model. So some of this data is huge. Right? We're not going to serve up through an API, 10 million records coming back. So I can actually get paging, and Looker takes care of doing the limits for me behind the scenes. It's completely abstracted from me. I can just say, here's the data I want. I want page 6. It'll tell me how many come back. The other key for us was export, right? One of our requirements is some of our customers like to take this data from the portal, put it into their own accounting system, so rather than have to go through and write an export system to do this, there is export functionalities built in Looker. We essentially just proxy them straight through. So let me talk a little bit about what we built. And I might have to use the mouse here to point to some of this. So what we really did here was we built an API layer on top of the Looker API. We kind of extended it a little bit. It served a couple of purposes. The first thing was our application is a SPA, right? It's a React application. It uses JWTs. Obviously, I have to have something to convert that JWT into Looker. So our custom API that proxies over to Looker is handling the security from the JWT, turning it into the Looker model. But the other thing that we did that I think is the key to this is we built a little metadata engine on top of Looker. So if you see the API layer in here, well, basically what happens is it's just let me find my mouse. There we go. You guys see that? Okay, so all of our app is really just HTML5, React, compile down, put in a storage bucket, load balance through cloud load balancing, right? Boom, there's your HTML5 web application. All the magic happens here in the API layer. So pretty much the JavaScript from here is making AJAX calls directly to the various microservices. The one we really care about here is this reporting API right here. So what this guy does is we've persisted the metadata around the Looker model into Cloud SQL. So this guy can actually go look up all of the different available columns in Cloud SQL for you, right? Because I know who you are from the token. I can go say, what queries, what reports do you want? And essentially, that's just some custom storage that we've done. And then this guy just runs a builder pattern and proxies over whatever that request was to the Looker API, which in turn generates the BigQuery SQL, returns it back, proxies it back to the front end into a standard JSON format. This is really, anybody familiar with the open-close principle? What this has done essentially is allowed us to extend this with really writing no code. I can build another Looker model. I can put it into our configuration database that could point to any data I want and expose it through this application, through this API, with a configuration only. Right? I have to write the lookml, which is the abstraction layer. I obviously have to have the data, but I don't have to do any additional code besides enabling it in my metadata layer for the customer to get it or the portal to get it. So now as we extend and you go from those 100 reports, if I end up with a new request, I can build a new Looker model. I can put it into the app, and security is actually put on the model layer. So you might see a little later the report builder, which kind of gives us some self-service as well. So we actually allow folks to come in and customize what they want this to look like. So they can go into our web API using the metadata and say, there's 700 columns available here. I care about these 6, and I want to sort by these, and I want to filter by these. We'll persist that in Cloud SQL, and essentially that just builds it's a builder pattern, right? It's just a straight proxy to Looker. So as long as we have the Looker model, I don't even want to know how many permutations we could get, but it's flexible. We provide some out-of-the-box stuff, but the customer can actually take the out-of-the-box. They can modify it. They can save it. They can share it with their coworkers. They can share it with other people. And that's all facilitated from the reporting layer. The other big thing that I think we need to talk about here is, the title of the session is how we scaled this. Everything in here is completely scalable through GCP. So the API layers all live in an app engine right now. We may move that to GKE. That seems like the logical progression. When we started this, that wasn't a thing. Looker is actually, we're not using hosted by Looker, we're self-hosting Looker inside autoscale VMs. So we can expand that out as much as we want, and obviously BigQuery is BigQuery, right? You can do as much as you want with that. And we're on a, there's a couple of pricing models on it. There's fixed cost, and then there's pay-as-you-go. We're on a fixed cost for that. Is there anything else? Security. So one of the challenges, too, that we really needed to do is the goal here was have one API, and based upon your token, I only return your data, right? So we have all of the data in here. The personas that use this application, everything from that single merchant who might have one location to maybe a regional manager that has 100 locations to maybe our own internal customer support people that service the entire portfolio. So we really wanted to ensure that the security trimming was done at the data layer. So what we're actually doing is, as we provision users in this application, we're using Cloud Pub Sub, and we're actually pushing the data access IDs. It's just location IDs. We call them merchant IDs, but think of it like individual locations. And we push them to BigQuery. And in Looker itself, we join to that table. Performance is to the point where it can handle someone having 200,000. A customer support person might have access to 300,000 locations. We actually security trim that right in the layer. So when you pass over the Looker query, you're only getting back your data, which is fantastic. We don't have to manage that at the API layer. We keep track of it, we pub sub it out, and we persist it to BigQuery, and we do a join on the data to right there get the constraints, which is, I don't know if anybody's ever experienced that. That's a huge problem to solve. BigQuery has been a lifesaver for that. Most our relational systems could not handle joining on something that big. So Mark talked about the Omnichannel, right? Another key to this is we're just looking at the merchant portal, the application we built, as really just the first consumer of this. This reporting API that we built, we could stick Apogee in front of this, give it an API key, throw it to a developer, and the developer can get the same access to the exact same data. You don't have to play the discrepancy game. Everything is going through a single channel, which guarantees that you're getting the same data no matter what from a single source. So I kind of alluded to the performance. You can probably expect that that's probably the biggest, we've solved most of the other challenges on our design goals. The 2 to 3 seconds that you saw earlier was kind of what our product team wanted to strive to. That's the biggest challenge in this, but we've come a long way. So when we started this, 18 months ago, roughly? Since then, last year, they announced some custom partitioning for BigQuery. We have applied that, right? So putting in partitioning, lowering the set of data that you're actually querying against has improved time significantly. And we've actually applied that on every single call. So every single model that we have has a primary date that we have set in BigQuery as the date partition. And we require the API calls to pass in some kind of range, right? I can't let you go through the whole data set. So I think the max you can go back is maybe 2 years. I mean, it is a filter. You can say I can take 7 days, 30 days, yesterday, specific date, but we have to constrain the data set. So you're not looking at the whole, lifetime of the data model. The other thing that we've been experimenting with and has been, I think is going to have some huge progress is nested repeated. I talked about we have disparate data sources, right? Well, some of those kind of fit together in kind of a hierarchical pattern. Right? You have this concept of a batch when you're doing credit cards. Inside that, there may be multiple transactions. Well, nested repeated is a great way. Instead of doing a traditional RDBMS join, right, you can actually put those transactions as a column inside BigQuery as another nested table. And there's an unnest feature which Looker speaks very well, and it's lightning quick. So we're migrating, we're experimenting a little bit with moving our consumption layer a little bit more to nested repeated and see if we can get some performance improvements. So far, it looks really promising. The last thing that I'll just mention is, widen flat, right? The less joins you have to do, the wider it's columnar. So I think most of our models are around 600 to 800 columns, and we're exposing all of those in our consumption layer, right? Where we've aggregated the different data sets together. We go flat and wide and disparate. It's fine, leave them null. You only get what you ask for back from BigQuery, right? So if you're only asking for these 8 columns, you're only gonna go through that. The data set's only gonna peruse 8 columns. You can have that as wide as you want. I'm sure there's a physical limit, but I don't think we've reached it. That helps when you're looking at performance. Like, you can do these aggregations on the fly, you can join them together, but what we found is by flattening that out in the consumption layer and having our looker model point to the flattened table, you get much better improvement. Okay, so here's some real world examples. This is just from partitioning properly, right? We started out, these are 5 different kind of reports that we've enabled through that everyone gets. You can see in here, 2x is the worst we did, just from partitioning. Some of them got to 10x. You can kind of see a correlation between data processed and time, right? This is the key. First, I think, is always apply a partition in every query you're doing, especially if you're going to expose this out real time. I'm hoping the nested and repeat it can get these even further, and we're probably averaging in the 5-second range right now. If you think about it, it's still pretty impressive when you're perusing an entire petabyte data lake in real time. I think that's all I got. Mark's going to show you some actual slides of the app. Thank you.
Thanks, JD. So while we're talking about that, what I want to go over is a little bit of the app, because like I said, we started on this journey. We've been on it for quite a few months with some partners and my internal team building this app. This is what it looks like. One of the keys, like JD said, this is the look and feel. Those top visualizations come out of that model. They come out of BigQuery. We can get 7, 10, 30 days, 2 years worth of data out of there, come through that API layer. The cool part about that too is I may have different business partners. I have a bank in Canada that just wants me to send them a visualization from our data lake. People don't want a report, don't want things like that. Other people just want an API and they want us to give them the data. If I want to settle and I'm a developer, I want to get that. So when they log into the portal, they'll see their data here. If they have their developer develop against our API book that we're putting out there, they're going to get the same data. If I ship this visualization off to another portal and let somebody put it in their portal and display it, it is the same data, because BigQuery and that architecture that JD has shown you allow you to do that. The reason I showed you the demo earlier is we're starting to roll this. This portal is reality, is going out. These are the reports. We found that a lot of the reports you make, and JD alluded to it, how many people built systems where you built a report and that guy needs this column, the other guy needs a different column, and all of a sudden you end up with just a ton of reports. Because BigQuery allows us to put all those columns out there, allows us to get that. This is the set of reports that we have for a worldwide audience right now, and we're rolling it out. It's not the 100 permutations you used to have. What we've found here is those visualizations, again, come through the Looker API from BigQuery. We've built a custom report tab down here, and this, I think, is part of a pretty cool design. Some of our partners and some of our design team came up with some of this. Is those columns are down there. Those come from the same API. They've been delivered. And that what you can do is, I talked about before, we have to service everybody from the small mom and pop to the big guy. This little custom report thing here is kind of what I would call the iPhone of reporting. It allows you to take on and remove and add, sort any of the columns on that report. So when we hit that API and get all the data, we're grabbing all the data. It's there. It's instantaneous. So I can put and remove things from this portal as we go. And that way I don't have to make 200 versions of a report. It's all sitting there, all coming through that same architecture from one database in the background. Pretty cool, I think. So here's the fun part. I showed you the marketing video because this is rolling out today. We have gone to pilot in the UK, and we have a worldwide rollout strategy over the next 3 months. Kind of interesting that we're here. It's like we're rolling out and we're here on stage talking, so that's kind of fun. But what we got is we got a multi-region migration. We've started to consolidate applications across the enterprise. And we actually, Hadoop, some people think it's new, we think it's old. We've actually retiring our Hadoop infrastructure that our finance folks were working on. We have started to consolidate with performance of BigQuery and the GCP platform. Kind of had that kind of any tool mentality too. We've been able to put different tools up against this. Looker, other BI tools that we have in-house, let's face it, we all have them. You all might have Tableau, MicroStrategy, Business Objects. They're loose against this platform, and we're allowing people to use them. We've let our data scientists get in there. We actually, with the backing of our CIO, did a few ML projects this year. We went against the same data using some of the products that GCP, Google has out there. You know, typical ones, the easy ones are attrition modeling. You can do attrition modeling around the world against the same data that's out there for the portal that's coming through the APIs, all those. Our internal customers have found it very, very useful, because now it used to be the data was in all these different systems. Now you got this thing called BigQuery that I can, and that data lake that I can dump it all into, that they don't always have to come and ask me for that one extra column or this. Data storage, as we all know in the cloud, is pretty cheap. We store everything. That's the premise of the data lake, right? So now nobody's looking for that additional column. When we need that additional column, like we showed you on a report, it's there, because the technology architecture that JD talked about works. It's going live for us. And some of the external applications that are out there, we will be able to, as we get that book of APIs launched through Apogee, we'll be able to give people that book of APIs and let them hit the thing directly. Here's our rollout plan. Like I said, we're scaling up to the world. Here's the title of the presentation, right? We've been through UAT. We have our regions around the world. We really talk about 4 regions: US, UK, Canada, and the AP. We're rolling out our plan, and we're doing our load testing. We'll have 10,000 users on this April, rolling to 25 in May. We'll have a full 40,000 on by June. And as we go through the year and we migrate our other divisions on there and see the adoption come forward, we anticipate having the full 100,000 to 120,000 users on this platform, hopefully by the end of the year. Reason we think that, and I'm just kind of pulling this out, I've anonymized this, but like I said, our design team has done a great job. My team has done a great job delivering this. Our partners have done a great job working with us to get this out here. But these are a few of the reviews. And our old portals, we designed them for us. They worked. But this is the first time when I look at this, and we get people that have actually looked at this thing and says, you know what, from different personas, different levels of the organization, this is exactly what I want. I can find the information I need. I don't have to wait for it. You can see some of the comments. The custom reports, really, really useful. People have claimed they've taken 20-minute jobs down to a minute, but I just think it's the technology, the design, and the things that Google, Looker, and other partners around here, there's more of them, have brought to bear that allow us to deliver this for our customers. So honestly, you can tell I'm excited. It's going to be fun to roll this out over the next year. My team, it's been challenging. We've learned a lot. It's not a smooth road. There's a few bumps. We've learned a lot, and you will learn a lot. The things changing, but it can be done. And really, that was our story for today, is that it's out there, it's going out, and it does work. But that is really, I was gonna do a demo, but I say I'm running a little short on time there. These are the partnerships that we've worked with from here.